that's available to all staff. Before we talk getting stuff from the web, there's something that I thought at the last meeting I'd start is just, here's an R package people might want to know about. And one I hit in the past week was I was just wanting to make a nice little map of R use around the world, because New Zealand was, by the metric I came up with, second highest per person in the world, just behind Singapore, which is not actually surprising if you know that the Singapore government has pushed really heavily to get their people onto using R for reports.
Is there a reason for that?
I don't know their specific reasons behind that, but they move very heavily to support government workers learning R. And I was looking around for making a map, and there's the maps package and there's ggmap and things like that. But if you just want countries and colours or a globe of the world with grid things, you actually want the R world map package, where it's really easy to make a pretty map of the world with coloured in areas. And when I was hunting around for it, there was someone who made a rotating globe coloured in thing of the Arctic area and had the R code for generating it. So they made that rotating animated GIF at the top from those kind of steps. But basically you just have a table of country identifiers and numeric values, and you say to the R world map, make me a map with this data, and you get a pretty map. So I thought, that's a package I'm going to occasionally want to come back to.
Can you use it as a base image to put data on the top of that?
Yeah, just like any map, you can use a base. You can effectively use a base and plot over the top. The thing you do need to be a bit careful about if you're working with large scale stuff is the projection of the map, how it is lining up latitude and longitude. It's not too bad when you're at sort of New Zealand and smaller scale. It doesn't matter too much. When you say, put these points here, they'll be about right. But when you scale up from that, you can start to get things misaligned if you're using the wrong map projection. Actually, he said, I went through, there's a maps projection package, he said, with all the different maps projections. Yep.
Use the stat.
Yep. You can just use maps and then use points after using maps to put the points on the map.
Yeah, but then I will use the stat package.
Oh.
They want it in a certain format.
Okay.
So you have to create a certain type of object to be able to
Okay, the whole spatial polygon thing. Yeah, okay, that's incidentally my world map of R, just to show you that data. And I said make it, and there's it's not incredibly difficult. You code and made it. Why I dived into here though is there is every map projection overlaid. So as I said, it can make quite a big difference to how things appear depending on the kind of map projection you're making, or indeed like that. The base one is rectangular and does a pretty good job most of the time, particularly on rectangular areas like the Greater New Zealand. So most of the time you don't care. Okay, getting data from the web. In an ideal world, they just offer you a CSV. You can't get much better than that. And for example, the USGS or indeed GeoNet, if you go and search for earthquakes and you set the details, there's output options, and I'd like it as a CSV file. And in those kind of cases, if you get that file, you've got the web address for that file, and that web address will generally include the information that you sent in order to generate the CSV. So you can cunningly hack that and disassemble it and reassemble it in R to get whatever you like by repeatedly sending CSV requests with different parameters to the server. So, for example, if I say beginning 9th of November 2011, ending in September 2011, ending November 2011, by week, essentially, so between a first and a second date, then using a whole bunch of paste functions to assemble the URLs. Then I build up a list of all of the returned CSV files. This is where I'm starting to take advantage of a few R settings and using lapply, list apply. I've got a list of URLs and I am funneling them through running a read CSV command for each one. Because I could just be going read CSV, here's the URL, and it would read it. But because I'm assembling them, I run that, and I'm sticking all of the CSVs together with the bind rows from the deployer package, and getting all that data. There's my 5,650 earthquakes that have come in because it offered them as a CSV, and I could hack the URL and pick out the bits that I want. That's the best of all cases. They give you what you want and you can tweak the settings for what exactly I want. Can't ask for more than that. Then you've got tables on the web page. This is probably the second best option. So I'm getting data from Wikipedia. And there's a table there. There's unequivocally a table with stuff in it. Okay, in this case, if there's an actual HTML table on the page, what you probably want is the rvest package for readme the data out of that table on the web page. So I can say, here's a web address. For those not used to Deployer, the kind of workflow analysis tool, you pipe together several steps. So I go, here was the web address. For that web address, read the HTML for that web address, then take that, find the HTML nodes that are tables on the page, find the tables on the page, fill in the blank details on the tables, because that's the big problem with things on Wikipedia. You only get the first entry and then it's blank for the next ones down, and store that in a list called HTML tables. So I run that, and it has plucked those tables out of the web page. In this case, 2 tables on the web page. So what you generally have to do in this case is just work out which table your data is in. And so you have a look at the head for each of the tables, the top of the tables, and I go, yeah, that seems reasonable. And I check the other one to be thorough, and I go, yeah, well, that's not what I was wanting. So I say it's the first one, and then because on the web page the names are not R-safe, I do a conversion from the existing names to R-safe names. And then I've got data I have pulled off the Wikipedia page. So that's kind of the second best case. It's on the page, use rvest, find which table it was. Third case, embedded fixed width data inside a web page. What that looks like, is the kind of thing that I decide I want the moonrise for an entire year for moonrise set for a particular latitude and longitude. Let's say east 172 degrees, south 45 degrees, time zone. Actually, I would like it 0 because I want universal time. And we'll make it moonrise and moonset because I'm interested in when the moon comes up and comes down. So once again, that is a web address, and I can use that web address. And once again, it is details at the top that I can set. But technically, this is a web page. So it's giving me something that if I was to look at the source of the web page, the raw code, there is web page codes in this stuff. And then it goes into what's called a pre-area, where it is a traditional fixed width kind of file. And there are tools for reading fixed width files in R, fixed width commands, but the trick here is you generally have to slice up the file to the bit that you want, and then you have to read in that bit. That's kind of the way of getting that information out. So I'm doing some study on moths, and I want to know when the moon is in the sky, or I'm looking at earthquakes and I'm ruling out the moon from affecting earthquakes. And in this case, you can see I'm loading the reader library because I want efficient fixed width processing. I've got a URL, and that's 2012s for Wellington. And I say read fixed width for this web page, but in reading it in, I'm skipping a bunch of lines and I am only reading a certain number of lines. So I'm pulling the bit out of the middle of the page.
Did it make it look shorter? Not actually reading?
It means I'm not going to be reading what is, to me, the rubbish above and below the web page codes. And that also means fewer errors when it reads it in. I do have to say fewer errors because you'll see there's a whole bunch of red in console now. That was caused by the fact that there were blank entries in the data, and it was questioning that. They were legitimate blank entries because the moon is a 12.5-hour period, so it doesn't necessarily come up and go down in a 24-hour period. So if you have fixed width data just sitting on a page, once again, you can read it in from the web address, but if there's other stuff around it, you kind of have to chop it out. Now, JSON. Horrible, horrible JSON, I say, as a non-web developer. JSON is a format very popular for data for web applications. And one of the times you'll see JSON is if you see a really fancy interactive graph on a web page where you are mousing over it and getting data points, that's almost certainly, because it's being handled through JavaScript, got JSON data in behind it somewhere. So in theory, you can extract the data that made up that graph, in theory. In practice, it means a lot of looking through, once again, the page source. I might just need to, I've lost the view page source command. Oh, there it goes. And after I've looked around for ages, anyone would think I checked earlier and jumped straight to line 224, where it turns out there's a whole lot of JSON format data, which involves lots of squiggly brackets and lists of things and square brackets and commas and stuff like that. Now, there are libraries for handling JSON data and organising it, like JSON-Lite, if you can extract just the JSON data. That tends to be the tricky part in embedded cases like that. The other time you tend to get JSON data is in services that it's some kind of computer at the other end delivering data for a web service. So if you are using R with Twitter, whether you are conscious of it or not, you are getting the data in JSON format. It's just you might be using a package that is automatically fixing it for you. And in this case, because I was doing birdsong analysis, went off to the Zeno Canto birdsong site, and there was a search box, and I searched for all New Zealand. I think I might need to, advanced search, country. Okay. In behind this is JSON format data, and if I started viewing source and tracking it back and seeing what links loaded, eventually I get everything that was making this up pretty. So I might load the JSON-like data. I might say there is the technical behind the scenes address that I've had to have stepped back a couple of steps through the source to find. I'm actually going to download it on this occasion, then read it in. So I use the download file command and just save it locally. And then I'm going to use from JSON from the JSON library to understand that file. And I get a list of things where that list of things includes a data frame of the information that I could extract that data frame, that tabular block of data. Just looking at what it looks like as a file, and this is very similar to how tweet data looks if you actually look at it. Lots of squiggly brackets and quote marks and colons and things like that. The real problem with JSON, as far as most people are concerned, is it's not tabular data. It's like XML. It's a tree diagram of possible choices. So sometimes some things might have a location, other things might not have a location. And that's why we need helper libraries to actually keep track of it. Okay, a couple of other alternatives. Sometimes there is just a package that someone has gone to all of the trouble of working out how to get the data, so you use that instead. WBI for the World Bank indicators. And then you spend ages reading the documentation, working out what the code number of the report is you actually want, and things like that, which I have to say is the big issue I found. Is this, X43, whatever? If something only lets you in with a password and stuff like that, in theory, and I have to say that we're very much in theory here, there is a helper program called curl, which R can access through the rcurl library. So curl is installed on your computer, I can talk to it. Where you can say, this is the username and password for logging in, for setting up the cookie, for knowing who I am, and then you start downloading things through using curl. So that's verging on the horrible technical workaround stages. It also means you're putting usernames and passwords into scripts on your computer, so that's potentially a sensitive thing. And the final option I've got, a bit out of left field, is Firefox has an add-on called Selenium, which is designed for web testing things. So you can automate use of websites in it. And R has a helper library called R Selenium for talking to Selenium. So the idea is you could go into a website on Firefox, you could put in your username and password, and then you have a script that says, you know, download the page and then push the button labeled next, and then download the page and then push the button labeled next, and so on and things like that. It's kind of the if you have no other way of getting the data out sort of choice. You can potentially automate Firefox to keep pushing buttons on the screen. But that's, once again, those last two alternatives are pretty horrible. So that's some general options for getting stuff that's out there on the internet. As I said, most stuff, either there's a package for it, so for Twitter, I'd use the Twitter package rather than try and do all of the handling of it myself. So when I do a sentiment analysis of Donald Trump's tweets, I use the helper package. For most cases, ideally it gives you a CSV, but rvest for reading the pages, tables off the page, tends to be the common one. If you can't, it's probably being constructed with JavaScript just in the web browser, and it's actually JSON, rather than truly being an HTML page table. In which case you figure out where the data is coming from and you try and use JSON to get it. So those are the options that I know of for getting stuff from the web. Questions or comments and free discussion? I might stop